Factorising Complex Quadratics. We've looked at a number of different techniques for factorising. So we've looked at common terms, we've looked at sum and product, and we've looked at difference of two squares, and we've looked at a four terms method. And the sum and product method we looked at previously only works whenever we've got a quadratic where the x squared term has a coefficient of 1. So something like x squared plus 5x plus 6. But now we're going to look at it if we have a coefficient of x squared which is not 1. So something like 2 or 3x squared. And what we do is we use a combination of the sum and product and four terms method. Only this time the product is the product of the coefficient of x squared. So in this it would be the 2 and the 6. So the product here would be 12 rather than 6 as it has been before. We then look at our two numbers. We replace the x term with these two values of x, and then we group to factorise. So just on that, if you can remember the four terms, so that was if we had 2x squared plus 4x plus 2x plus 2. So we had something like that, then we split it into the pairs. We took out what was common, so there's a 2x common, and we'd have x plus 2 inside the bracket. We'd repeat the bracket, and we see what goes outside. It was a plus 1. And then because the 2x and the 1 are multiplying the same brackets, then we went to 2x plus 1 and x plus 2. So that was our four terms method of factorising. So now we're going to combine it with sum and product, only we've got the product is, rather than just the number, it's the product of the coefficient of x squared and the number term. So example I, what we've got is the sum, is the number of x's we have, so that's 7, and the product is the multiple of the coefficient of x squared and the number term, so that's 2 multiplied by 3, which is 6. So numbers that multiply together to give 6, we're thinking of 6 and 1, or 2 and 3. And those that add together to give 7 is going to be 6 and 1. So what we do is we try and get four terms, so we can use our four terms method of factorising. And to do that, we replace the 7x with 6x and 1x. So we'll have 2x squared plus 6x plus 1x plus 3. We split these into their pairs and we perform simple factorising. So what's common between 2x squared and 6x? So that's 2x. Inside the bracket then, 2x multiplied by x is 2x squared and 2x multiplied by 3 is 6x. We need to repeat the bracket. And then we see what needs to go outside to multiply x plus 3 to get 1x plus 3. And that's a plus 1. And then because both brackets are the same and they're being multiplied by 2x and plus 1, we can write it as 2x plus 1 multiplied by x plus 3. And that's it factorised. Example B, the sum is minus 4 and the product is the multiple of 5 and minus 12, so that's minus 60. So let's think about the factors of 60. So you've got 60 and minus 1, or minus 60 and 1, 30 and minus 2, minus 30 and 2, 15 and minus 4, minus 15, 4, 12 and minus 5, minus 12 and 5, and minus 6 and 10, and minus 10 and 6. So to get a sum of negative 4 and a product of minus 60, we're going to use this last one. So negative 10 and 6. So they'll add together to give minus 4. So we're using minus 10 and 6. So what we do is we replace the minus 4x with minus 10x and 6x so that we have our four terms. And we've 5x squared minus 10x plus 6x minus 12. Split them into their pairs and perform simple factorising. So there's a 5x common in the first two, and inside the bracket is x and minus 2. Repeat the bracket, x and minus 2, and then to get from x to 6x and minus 2 to minus 12, you need to put 6 outside the bracket. So then we've got 5x plus 6 and x minus 2. Example C, the sum is minus 8 and the product is 5 times 3, so that's 15. So we need to think of all the numbers that multiply together to get 15. So we've got 15 and 1, we've 3 and 5. But none of those will get to a sum of minus 8, but we need to remember the fact that two negatives multiply together to give a positive. So we can also have minus 15 and minus 1, and minus 3 and minus 5. So to get a positive product and a negative sum, we're going to have to use the last pairing there. So our two numbers are minus 3 and minus 5. So we replace the x term, the minus 8x, with minus 3x and minus 5x to get our four terms. So we've got 3x squared minus 3x minus 5x plus 5. Pair them off and perform simple factorising. So there's a 3x common here, and inside the bracket is x minus 1. Repeat the bracket, so we've got x minus 1. And to get from x to minus 5x and minus 1 to 5, we need to multiply by minus 5. So our two brackets are 3x minus 5 and x minus 1. And lastly, example D, the sum is the number before the middle term. Now, this obviously looks a wee bit different because we've got a mixture of x's and y's, but it's the same idea. So the sum is still minus 1, and the product is going to be 6 multiplied by minus 1. So that's minus 6. So if we look at the pairs that multiply together to give minus 6 and add together to give minus 1, so we've got minus 6 and 1, or 6 and minus 1, 2 and minus 3, or minus 2 and 3. So to get a sum of negative 1 and a product of negative 6, we're going to use 2 and negative 3. So 2 take away 3 is minus 1, and 2 multiplied by minus 3 is minus 6. So the same steps as before. So 6x squared. Instead of writing minus xy, we'll write plus 2xy, minus 3xy, and then minus y squared. Split them off in their pairs and perform simple factorising using common terms. So we've got 2x is common to both, and inside we've got a 3x plus y. Repeat the bracket, 3x plus y, and then we think, well, how do we get from 3x to minus 3xy, and from y to minus y squared? So we need a minus, and we also need a y. So then the factorised form is going to be 2x minus y, and 3x plus y.